May I open this meeting?
Yes, please.
Okay. Good evening to all participants and for Mr. Satria. Let me introduce myself. My name is Rifa Salma Salsabila. I'm graduate student from ITB. Now I'm as a Master of Ceremony for this session. This is session 2 for this day. It will be held from now until 9 o'clock, 9 p.m. This session, the topic of this session is the hypercumulator plans, challenges and prospects. And let me introduce our speaker, Professor Dr. Satria Bijaksana. He's received a bachelor degree from ITB and master degree from Memorial University Newfoundland, Canada, and master degree from Memorial University Newfoundland, Canada. Position now is professor on ITB, and his previous publication over 121 publication on ResearchGate and over 1,126 citation. And his skill and expertise: rock magnetism, environmental science, magnetic properties, and latest project, environmental and agricultural geophysics, ICDP, TDP, Lake Tawuti Drilling Project Indonesia, Petromagnetic Study of Volcanic Product, rock magnetism in volcanology, and rock magnetism study of Clut Volcano East Java, Indonesia. Please, to all participants, please welcome our speaker, Professor Dr. Satria Bijaksana. And for Dr. Satria, time is yours. Let me stop my screen.
Okay.
And you can share your
presentation. Thank you. Good evening, everyone. I'm sorry I got confused with my timing, but the important thing, I'm here now. So let me share my screen. Okay. Okay. Can you see my screen now?
Of course, Mister, but not a full screen.
Okay. Can you see it now? Okay. So this evening I'm going to talk about something probably not quite geophysics yet, but I dress accordingly. I have my green shirt here to suit with the theme of today. Okay, so I'm going to talk about what's so-called the nickel hyperaccumulator plants. Okay, and this is one of the thing that we do at ITB. We try to find ways basically to use rock magnetic methods in various applications. And this work, we carried out this work for over the years. And one of the students involved is the now Dr. Abdul Mujahid Hamdan. He was my PhD student for a number of years, and now he is a faculty member of Faculty of Science and Technology in Islamic State University, Araniri in Banda Aceh. Okay, so this is the researcher that involved with some of the works. And this just to show you that sometimes it's very important to basically work with people from different fields. Okay, so this is Dr. Abdul Mujahid Hamdan, and this is Miss Sylvia Janatul Fajar from ITB, and this is Dr. Kartika Kirana from Pajajaran University. This is Dr. Dahrin from ITB, and this is Dr. Ayan Choa from Tadulako. So Dr. Ayan Choa is basically a biologist. So she specializes in different or unique type of plants that include these nickel hyperaccumulators. Okay, let me introduce you to these amazing plants. They call it nickel hyperaccumulators. So metals basically is considered to be toxic for most of the plants. But amazingly, some of the plants could not only survive high accumulation of metal, but the plant itself accumulate metals. And one of the metals that uh, accumulated in this type of plants, including nickel. Uh, Probably some of you are more familiar with plant that probably we used to we eat kangkung or water spinach. So kangkung is actually hyperaccumulators of iron. So kangkung could accumulate uh, high amount of iron in their tissues. So there's a possibility that if you have a kangkung for lunch, you will feel sleepy because of high content of iron. Okay, but some of the plants they accumulate other metals, and in this occasion, I will be talking about plants that accumulate nickel. So generally, there is a term that is called hyperaccumulators, nickel hyperaccumulators. Okay, so this type of plant could accumulate more than 1,000 ppm in their tissues. Okay, and certain species of nickel hyperaccumulators could accumulate up to 25,000 ppm. This is quite high. If you look at the number, 25,000 ppm is about 2.5%, right? Can you imagine the plants that 2.5% consist of nickel? Okay, so one question is why some plants accumulate metals. Okay, so this is interesting question. Some of the plants actually accumulate metals because this is how they adapted themselves into a certain environment which is probably uh, quite high in terms of metal contents in the soils. But apparently, some other plants accumulate metals in their tissues is a way for preventing themselves to be eaten by animals, for example. Okay, so this is like a self-defense mechanisms of the plants. Okay, now if you look at this condition, it's kind of interesting. I mentioned earlier that some plant could accumulate up to 25,000 ppm. Okay, do you know how many percentage of nickel in soil? Okay, so if you look at what's so-called uh, soil that is rich in nickel, the soil that rich in nickel could be called rich in nickel if the nickel content is 1%. But here you have plant that consists of like 2.5% nickel. Okay, that's why this the presence of nickel hyperaccumulators become an interesting phenomenon, because then people thought, okay, can we mine nickels from plants instead of mining nickels from soils or rocks, you know? So this is what's so-called phytomining, okay? Mining through plants, okay? So this is a interesting propositions, and it has been tried in several countries, and it's kind of quite successful. No, not in a big scale, but it's quite interesting. Okay, the other applications of nickel hyperaccumulators will be what's so-called phytoremediation. So, for example, if you have area that has been used as a place for tailing, for example, of mining, then you have a different type of metals in the tailing, and this plant, this hyperaccumulators, is kind of useful in try to basically absorb all these metals in the tailings, for example. Okay, so the presence of nickel hyperaccumulator is kind of interesting. Now, where can we find nickel hyperaccumulators? Okay, now this is the interesting thing. There have been some intensive research in places like in Cuba, for example, and they already recognize 130 species of hyperaccumulators, nickel hyperaccumulators. Okay, small island group like in New Caledonia in the Pacific, they have 56 species of non-hyperaccumulators. Brazil is about 40 species, Malaysia 24 species, Southern Europe 45 species. But despite of great biodiversity of Indonesia, so far only about a dozen species are identified. Okay, so this is the kind of a point that basically sparked our interest in hyperaccumulators. Can we identify more nickel hyperaccumulators, basically, right? So this is the it's kind of interesting for us. Okay, the mistress of ceremony mentioned earlier when she introduced me that my background is in rock magnetism. Okay, so and it come natural that we try to basically use magnetic methods in identifying nickel hyperaccumulators. Okay, and the reason is kind of simple. Nickel nickel hyperaccumulators might also contain iron. Okay, and in its oxide forms, iron is magnetic. So this bring us to a question: can we use magnetic methods to speed up the identification of new nickel hyperaccumulating plants, basically? Okay, so we test our approach. We basically use different type of samples. Some of the samples are basically cultivated Alyssum murale and Alyssum corsicum. So these two plants originated from Asia Minor, and these two are probably at this moment is the most prolific nickel hyperaccumulator contents. So Alyssum murale and Alyssum corsicum basically could could accumulate up to 25 to about 30,000 ppm in their tissues. Okay. Now we also test our methods in for some natural samples we collected from Halmahera, the two species of Caesarea halmaherensis and Piper sp. And we also collected some sample from Southeast Sulawesi, different type of plants, Acacia auriculiformis, Acachuba occidentalis, etc. Okay, including the pine, actually, Pinus sp. So what we did is basically we did the magnetic characterizations of the basically the powder that extracted from the plants of nickel hyperaccumulators. We did magnetic characterization in form of measurement of magnetic susceptibility, magnetic hysteresis, and also we do the thermomagnetic analysis. We also did the ICP-OS, inductively coupled plasma optical emission spectrometer analysis, to look at the chemical signatures of the samples, also with the atomic absorption spectroscopy. The pictures on the right here is basically our all magnetic susceptibility meters in our lab. Okay. Now, this is the result that we obtained. We could see that this is interesting, that plant could have positive magnetic susceptibility, which is kind of surprising for us because we thought that a plant would be a diamagnetic at the most, you know. But again, we have uh, found that plants could have positive magnetic susceptibility, and this is so for well-known nickel hyperaccumulators. Okay. Now we also found out that for the suspected nickel hyperaccumulators, for example, these two plants, Cesaria halmahrensis and Piper sp, they also have positive magnetic susceptibility. And it's interesting because the non-nickel hyperaccumulators have negative magnetic susceptibility. Okay. Now, there's other species that have only 600 ppm of nickel, auricoliformis. It also have positive magnetic susceptibility. Okay. We have published our work in Journal of Geochemical Exploration in 2020. Okay, so this is the publication that we did. Now, our paper actually attracted uh, quite wide range of attentions, and the one of the media that basically cover our publication is BBC. Okay, so BBC basically put a special reports of our finding, and the title is kind of very bombastic. The rare plants that bleed nickel. Okay, so this picture is basically a sap of special kind of tree in Sabah that basically has 17% of nickel. If you look at the sap, it's interesting. The sap itself is green. Okay, the most common sap that we use is rubber, right? Rubber, people collected rubber sap, and rubber sap is basically white. But this is a plant in in Sabah that the sap is basically green because it's very high in nickel. Can you believe it? 17% is nickel. Okay. Now, our finding is also attract uh, interest from mining company. Basically, this we had a meeting with Antam, the state enterprise mining company, to test the prospect of phytomining and for phytoremediation in its concession areas. Okay, so we have a quite a nice discussion, but so far, unfortunately, due to the pandemic, we could not really do the field work as such because of the limitation in our movement, basically. But it's kind of interesting to to test this or to study these unique plants. Okay, it's interesting that these plants has the plants have a high content of nickel, and also the plants the tissues basically have a positive magnetic susceptibility. Okay, so we have been doing this for a number of years, and we receive funding from ITB as well as from the Ministry of Research, Technology and Higher Education of Republic Indonesia, and also from the Asahi Glass Foundation. Okay, that's probably all that I would like to discuss at this moment, and it's time for discussion. Thank you.
Okay. To all participants, whoever wanted to ask to Mr. Satria, you can raise your hand and deliver your question directly, or you can write on a chat box. Thank you, Mr. Satya, for your presentation. This is an interesting topic, but I'm new for this topic.
Okay, it's fine. This is I was asked by Dr. Wahyudi Panadi to give something is different, right? To give
Yes.
a totally different view, so people could see that geophysics could also be applicable to other fields. That there are other interesting things outside, right? So please feel free to ask me any questions.
Okay, to all participants, anyone to ask to Mr. Satria about this new topic? Okay, that's one question on a chat box. Could you read on a
Yes,
chat box?
this is from Khalil Ibrahim, right?
Right, Mister.
How are you,
From Khalil
Khalil?
Ibrahim.
How are you?
I'm fine, sir.
Khalil is my student actually, so my master student. So Khalil, thank you for the questions. Okay, so it's very natural to try to find nickel hyperaccumulator plants in eastern Indonesia because you have quite complicated geology over there, right? Uh, and as you could see, the number of nickel mining in uh, eastern part of Indonesia. So yes, there's geological correlation with nickel hyperaccumulators. In many places, the parent rocks or the basement rocks of the area where nickel hyperaccumulators grow is basically what you call serpentinite. Okay, so the most common place where nickel hyperaccumulators basically exist is serpentinites, and luckily in southeast Sulawesi or even in South Sulawesi, uh, we have so many area where you have serpentinites. Okay, so the uh, the thing that we actually use at this moment is basically magnetic methods, basically because we try to see correlations between nickels and iron. Okay, but maybe there are other ways. But as far as I know, for the most appropriate methods in geophysics that could be applied to uh, nickel hyperaccumulators is magnetic methods. Okay, but again, this is not the kind of magnetic method that normally used in geophysics. Okay, so for example, in geophysics, that there are different type of application of magnetic methods. One is the use of magnetic method in what's so-called geomagnetic survey. Okay, and the other one is rock magnetic methods. That is basically um, more into the compositions, magnetic composition of the substance. Okay, would that answer your question, Khalil?
Mr. Halil, maybe that's enough, Miss Professor Satria.
Okay.
That's one question again from Miss Harmita Lestari, Prof.
Okay. So based on your experience, do you have a suggestion we should know what geophysical method is in depth to dive into any field? For example, in other geoscience and engineering? Thank you. Okay. So this is the thing. Uh, Geophysics could also be considered as a, I would like to call it toolbox. We have so many tools, okay, and it's up to us where or where and when you want to apply the tools. For instance, you probably surprised if I mentioned that some of the geophysical methods found application in forensic. Okay, for those who are interested in this, I could show you papers related to forensic science, for example. Okay, uh, this is true. So the same thing, like can you identify the let's say buried people, buried person? Okay, using geophysical method, you could. Can you tell how long that buried person have been there? You could basically look at the property of the soils. Okay, so the geophysics could be used in any other field. The only thing that required is basically you have to read a lot and you have to talk to a lot of people, and then you'll find out what kind of things that kind of interesting. Uh, for instance, for instance, earlier I mentioned about our collaborators, Dr. Ayan Choa from Tadulako University. So just happened that I met her during a conference. Okay, and we had dinner together, right? We just talk and those kind of things, and then it clicked that there's something that we could do together, right? So the important thing for all of us is basically to have open-minded, to be open-minded, because you never know what kind of things that uh, uh, could be used. Again, geophysics in lot of sense are basically like a toolbox. We have so many tools that we could use, but how and when you use it is up to you. Okay, but again, please be open-minded and read a lot and uh, get to know other people's in other fields. Okay, so for example, can geophysicists become can geophysicists work for the police department? Yes, you could, because of this forensic science. Okay, that would require geophysics. Okay, I do hope that answer your question, Harmita.
Yes, thank you, Prof. Satria. Uh, I think maybe we should focus on one skill, but also we have to extensive knowledge of others' role in geophysics.
Okay.
So maybe we should focus in one role. For example, maybe in the seismic or seismology, but also have knowledge in deep in other role of geophysics.
Yeah, but again,
Thank you for
if you're very good in particular methods, you'll find a lot of application. No problem. Okay. So for example, if you are still students, it's good that you know that many methods. But when you become a graduate student, you probably have to focus on only on one or two methods. Okay, if you become PhD students, your your field will be very narrow. But if you're good at that particular narrow field, you could apply it in many applications, basically. Okay, there's a question from Dr. Wahyudi Panadi. Can we use a similar technique to extract gold? That's a dream, right? Can we basically plant special plants and harvest gold from the plants? Okay, this will be great, but unfortunately we haven't identified gold accumulators yet. We have iron hyperaccumulators, nickel hyperaccumulators, but so far we haven't got any idea about gold uh, gold hyperaccumulators as yet. Apparently, it is not always easy for gold to be associated with plant tissues, basically. Okay, so and true, gold is much rarer than nickel, but I got the idea. The idea is kind of uh, extraordinary. Can we mine gold from certain plants? That will be. But I will inform you if I come across to that plants that accumulate gold. Okay, this question from Rahman Fajar. Okay, are hyperaccumulators tree species really suitable for remediations of heavy metal contaminated site? Yes, there are some plants that actually being used for phytoremediations, but most of the plants are a brush, not tree, because it will take years for tree to grow, but for bushes, it will take only months or a year or two. So in many sites where nickel hyperaccumulator plants are used for phytoremediation, they use bushes, not trees. There's some trees that also hyperaccumulators, like the one that I saw earlier, the one with green sap, right? But people don't normally use this kind of trees because it takes like 20 years to grow. Okay, so people will try to find bushes, basically shrubs. In bahasa Indonesia it's called semak-semak, right? Instead of trees, because it grow faster. Okay, any other questions?
Okay, to all participants, any other question to Mr. Satria? If you want to ask directly, please raise your hand or write on the chat box. Okay, Mr. Indra Gunawan, you can deliver your question.
Okay, thank you, Miss Rifa. Thank you so much for Professor Satria. This is interesting topic. I want to ask one question for you. Can we detect the magnetic properties in the hyperaccumulator plant using the geophysical method on the field? For example, if there is a hyperaccumulator plant field that very big, and we measure some geoelectric or geo-EM, can this plant invert or affect the signal that we read by that instrument?
That's a good questions. I don't think anybody has tried it before, but probably I will doubt it, because normally this kind of plants would not grow in extended areas unless it's being grown on purpose. So naturally, this plant would not live in a field. Okay, just patches here and patches there.
Okay.
Okay, but you know, it will be interesting. What happened if you grow this nickel hyperaccumulator plant in particular spot, for example, right?
Yeah.
You could say, okay, like 100 meters over 100 meters, and then you try measuring the signals from geophysical method. It might work, but in its natural form, these plants are just basically spotted here and there. It's not
Okay.
concentrated in large number in particular area. But that's something that kind of interesting.
Okay. Thank you, Professor, for the explanation.
Okay.
Okay. Anyone else wanna ask to Professor Satria? Please raise your hand or write on the chat box your question. Maybe enough, Professor Satria. Oh. Anyone else from Leonardo Junior? Good evening, Professor Satria. This is my first time.
Okay.
in
Yes,
this
I could see.
material.
I want to ask, can these nickel hyperaccumulators be used in exploration and monitoring of oil and gas reservoir? Probably not. The nickel hyperaccumulators basically do not associated with oil and gas reservoir. Oil and gas reservoir are basically deep. You know, even in the places where there's a shallow reservoir, probably it's not a place for this nickel hyperaccumulator plants. Because as I mentioned earlier, these nickel hyperaccumulator plants only grow in a very specific geological setting. Okay, so uh, it's not associated directly with oil and gas explorations. I do hope this answer your question, Leonardo. Okay, I have seen Kevin Adiatama raise
Yes.
your hand. Kevin, please.
All right. Wait a minute. All right. Is my voice loud and clear?
Of course.
All right. Thank you, Prof. Satria, for the presentation. It's a really interesting topic because, oh, I forgot to introduce myself. Sorry. So I'm Kevin Adiata Herlambang. I'm a geophysics student at University of Indonesia, an undergraduate program. So it is a very interesting topic because it is the first time that I've heard about this method. I mean, I didn't, how's the word? Like, I didn't expect that geophysics could be used in a such particular way because, well, what I know is that we usually use geophysics methods for mineral exploration, oil and gas exploration, environmental and engineering exploration, but I didn't expect that geophysics methods can be used in such particular methods in this particular field. It's not really a technical question, but I just want, it is out of curiosity idea, Prof, that one is what? I just want to know if that geophysics in all, all geophysics major in every university includes an optional, like an adding curriculum, like alternative exploration, like this one, like this is a very unique mineral exploration, well, with the objects based on plants and maybe other methods, maybe other objects too, like for example, that Mr. Prof. Satria mentioned that we can use geophysics method to find dead corpse, right? I think that's the first one. And the second one, can I have an update on his particular research? Because I'm quite interested in here since I am a final year student, so I need to prepare the topics for my final project. Thank you, Prof.
Okay, thank you. It's very long questions, but put it this way. I answer your last question first. Okay, so for those who are preparing for a final year topics, I would recommend that during this pandemic thing, you find something that probably would not require you to go to the field. Okay, there are number of things that we could do with data that's already available. Okay, so this is one of the thing that could be done. So basically, during this pandemic thing, the topics for research for undergraduate could probably be data processing or data analysis, and but probably at this moment, unfortunately, going to the field and do the measurements is not is not the wise option. Okay, that's one thing. Okay, the second thing that's kind of important, it's when you choose the topic of your research for your undergraduate, it depends very much on what will be the next step for you. Some of the geophysics students, they want to continue their graduate programs, for example. Okay, in that situation, topics that probably more in depth into in particular field will be very important. But if you want to become a geophysicist working for mineral explorations or hydrocarbon exploration, I would recommend that you try to work with what we call case studies. Okay, case studies that probably there in companies basically, and I know that there are some companies that are very welcoming to students doing a project in their companies, for example. Okay, but again, there's other thing that I would call it different type of geophysicists or the different type of geophysics students. This is the one who want to punish themselves by taking a very difficult subject to tackle. I welcome this kind of people, this kind of students, because they want to prove that they are good at it. The topics probably is not in the main the mainstream of geophysics. For example, he or she will tackle complex analytical problem, theoretical problem. Okay, their field not quite popular in Russia, but this field called theoretical geophysics. Okay, this is for those who want to, in my terms, punish himself or herself in doing this kind of things. There's also some other students who probably incline more on instrumentation, not necessarily in geophysics itself, but the instrumentation part of geophysics. So they design a geophysics instrument, for example. The same thing with programming. Some of the geophysics students want to have experience in developing programs. So when they graduated, they probably would not deal with geophysics programming anymore, but they use their skills in programming to do other things, for example, right? But again, this is depends on each person. But I guess as an undergraduate students, you're welcome to try all of them. You could be anything you want. Okay. I do hope that answer your question, Kevin.
All right, that's a very great insight, Prof. Satria. Thank you so much for answering my question.
Okay. Any other questions?
Okay, any other question from the all participant?
Oh, Dr.
Professor
Indra
Indra.
again.
Okay,
Please.
I just curious one thing after get some explanation from you, Professor Satria. Is this kind of plan, this kind of hyperaccumulator plan, have some unique environment to grow, or it's just grow in everywhere, or there is any specific place that usually this plant to grow is maybe in the high magnetic field on there, or just spread everywhere.
Basically, it grows well. It's become endemic, actually. It's become
Okay.
endemic in a place where the soil is basically come from ultramafic soils or ultramafic rocks or things like serpentinite. So most of the time, this is endemic.
Okay.
But this is interesting. I went to the Philippines and talked to my colleagues in my colleagues in biology department at one of university in the Philippines. It's kind of interesting. Have you seen the plant that is called plant catcher? In Indonesia, it's called kantong semar.
Okay.
The
Yeah.
plant that basically catch insect.
Yeah.
Right. Now the question is why this plant basically trap insect.
To eat.
Yeah, but why they have to eat insect? Why they have to consume insect?
Maybe some kind of protein.
Now this is the thing. Apparently, there's some similarities in terms of we haven't really looked at this carefully, but some people have suggested, like my colleagues in the Philippines, that this nickel hyperaccumulators could be one of these plants, the one that basically could not really deal with the environment. They have to come up with some creative solution to their problem. Okay, including live with nickel. Nickel itself is poisonous for majority of plants, but some plants basically try to adopt living in an environment where nickel content is high, actually. Okay, so but it's interesting. This is the kind of thing that I would like to check to see whether this kantong semar or this pitcher plants actually, also nickel hyperaccumulators.
Okay. Okay. Thank you, Professor.
Okay. Any other questions?
Okay,
Okay. This
another question.
Bomer Lumban Toruan. These nickel hyperaccumulators can be used as indicators that there are nickel deposits around the plants. Okay, Bomer, nickel is a kind of different from any other deposit. As I mentioned earlier, nickel content in what's so-called nickel-rich soils is only 1%. So basically, to get nickel, you have to have a very large mining site. Okay, and again, finding nickel deposit is probably easy. It's not like finding gold deposit. Gold deposit are basically located in very small area, but nickel rich area is basically very wide. But you have to basically get huge quantity of soil just to get the nickel. As I mentioned earlier, the soil that is considered nickel rich only has 1% of nickel, and that considered to be a nickel rich soils, good for mining. So when you see the nickel mining in many places, it's basically just open site like it's not like you have to go into a cave. This is just like, you know, open site basically, but very huge tract of land basically. And if this kind of thing is not managed properly, this could become an issue, environmental issue. Okay, but again, the finding nickel deposit itself is very easy, because if the soil has 1% of nickel, that's nickel deposit. I hope this would answer your question, Bomber. Okay, any other questions?
Okay, any other question for Professor Satria? Maybe, oh, anyone from Tiara, Mister?
Tiara, okay. Okay, Tiara, this is interesting. At ITB now we have courses called agricultural geophysics. Geophysics for agricultural issues. And some of us at ITB actually conducting research on the things. We have some publication related to the applications of geophysical methods in agriculture. So yes, as an agricultural society, agricultural country, we could use the geophysics in in uh, in uh, in agriculture. One of the issue in Indonesia, for instance, is the problem with the use of fertilizer. Okay, so now in the international world, there is a term called precision agriculture, because apparently now people realize that in agriculture, farmers tend to overuse fertilizers and also pesticide. Okay, so for instance, there's correlation between the condition of soil, the electrical properties of soil, with the ability to absorb fertilizer, for example. There's a possibility that in some area with certain soil condition, it would require fertilizers. But in some other area, in some other spot, the fertilizer basically would be useless, because it could not really react with the soils, and the soil could be basically as good without fertilizers. So this is the kind of things that now geophysicists start to look into. Can we use geophysical methods for agriculture? The other example is maybe you heard about the intrusion of seawater. Okay, intrusion of seawater is a serious problem, and this problem is very serious in let's say in rice field. Okay, let's say that you have a rice field not too far from the coastline. Okay, and if there's a seawater intrusion to the rice field, then the rice probably would have to be somehow adjusted. For the agricultural scientists, they know that some variety or some type of rice could survive in saline environment, which means that even though there's an intrusions over there, this type of rice could survive. Okay, but in some for some other type, this is the rice would not survive basically. So, for instance, knowing the extent of the area that has been intruded by seawater is very important in agriculture, for example. Okay, and finding the area that has been intruded by seawater is not difficult problem for geophysicists. We could use geoelectric methods or resistivity methods to basically map the area, and you could see which area that has been contaminated by seawater and or not. So yes, Tiara, there are number of ways to basically use geophysical methods in agricultures. And when you talk about Indonesian farmers are relatively old and they don't know about the use of technology, then this is a challenge for us, challenge for you, because I'm old myself. Okay, so this is the challenge for new generations of geophysicists in Indonesia to basically try to explore the possibility of using geophysical methods in other fields, including agriculture. Okay, so we are talking about possibility of basically the use of drone, for example, for geophysical mapping in agricultural area, for example. So the possibility is endless. And I agree with you that yes, we have to find a right technology that could be applicable. And I believe firmly that geophysics is one of the field that could be applied in agriculture, especially in place like Indonesia. Okay. Okay. Any other questions?
Okay, any other question from the all participants? Or maybe you wanna ask directly? You can raise your hand. Maybe enough, Mr. Satria.
Okay. If no other questions, then thank you very much for inviting me. Thank you, Pak Wahyudi,
You're
for
welcome.
giving me a chance to share something with the audience here. And I apologize for the confusions about the time. But
No
the
problem.
important thing
No
is
problem.
now we have done the lectures, and I do hope that all of you have some use or find my lecture is stimulating, right? So this is the important thing. So especially I could see there's so many young people here. So probably geophysics in your time would be very different with geophysics in my time or Pak Wahyudi time, right?
Right.
So this is exciting time to be a geophysicist. Put it that way, right? If I could turn back the clock, then I would like to be as young as you are in this time. Yeah.
Okay. Thank you very much to Mr. Satria to your presentation. Now is a photo session, Mr. Satria.
Okay.
So to all participants, please to open your camera.
Before quiz session begins.
Yes, after this quiz session begins. Okay. Please smile so your face on the screen looks good. Okay, now for first slide, I will take a picture. 1, 2, 3. Okay. Okay, keep your smile. Now is second slide. 1, 2, 3. Okay. Now is third slide. Keep your smile. 1, 2, 3. Now the last slide. Keep your smile. 1, 2, 3. Thank you to all participants and for Professor Satria to your presentation. This is a really interesting topic and new topic to us.
Okay, thank you very much. And good luck with your endeavor. Pak Wahyudi, Pak Indra, thank you.
Okay, thank you very much,
I
Professor
leave the meeting.
Satria.
Okay, bye-bye.
Okay,
Bye.
bye. Thank you. Waalaikumsalam warahmatullahi wabarakatuh.
Wabarakatuh.
Okay, now to all participants, now is quiz session. You can answer the quiz in the link on the chat box. Okay, wait. Mr. Harmita, can you share the link? Or I will share it. Okay, that's the link to the quiz session. It will be held maybe 30 minutes, Mr. Wahyudi.
30 minutes, okay.
Okay. So please to our participant, copy the link because we will end this session and you can answer the quiz on this link.
And don't forget to come tomorrow. So
The last day.
yeah, last day, yeah. And there is a closing ceremony, yeah. And maybe some quizzes, yeah, for the last.
Okay.
Okay, thank you very much for all. Thank you very much for Ms. Rifa and Ms. Harmita and Pak Indra, yeah, and Rama, maybe, yeah, she's still here. Okay, and okay, yeah, okay, and I end this meeting. Thank you very much for all again, and see you tomorrow at 1 o'clock.